Hello, welcome to another episode of the Silk and Steel podcast. I'm your host, Carl Zab. Today we have back on our show Mr. T, who has been a previous guest on the show to talk about the tech war between US and China. And today he will have more update for us. So welcome back to the show, Mr. T.
Thank you so much, Carl, and thank you for having me back. It's always a pleasure.
So this U.S. tech war is an ongoing saga. Many people have expected that maybe you will subside with the Trump administration's passing, but it looks like this is it's not going away anytime soon. Like specifically, you have done a couple of Twitter thread on the situation of the chip shortage caused by the U.S. policy, right? But the specifically there's a bottleneck in the supply of semiconductors right now. Do you want to talk about that? Just start talking about that.
Yeah, sure. So, back in call it like between September and November last year, if you recall, the U.S. imposed bans on SMIC. Last May, the U.S. also imposed bans on Huawei, right? And those bans were not about Huawei or SMIC selling into the U.S. They were about preventing anybody that was using U.S. technology, so that even includes like international companies, non-U.S. companies, from selling into Huawei or SMIC, or providing services to them. So that most importantly, that cut off Huawei from semiconductor fabs, and then SMIC is a semiconductor fab itself. It cut off SMIC from its upstream equipment suppliers, as well as some of its like key chemicals suppliers. You need a lot of specialty chemicals in semiconductors.
So for my audience who might not know, SMIC is a semiconductor maker in China, in mainland China, and it was set up around 2000 when the Chinese government wanted to attract talent from Taiwan. They got an investor and some tech guy tried to basically replicate what TSMC, the Taiwan Semiconductor, did for the Taiwanese economy, making domestic semiconductor production in China. And now, SMIC has, after more than a decade, almost 20 years, they finally at a place they're about to advance to the next level. I guess US see that as somewhat of a threat, or either that or they want to just kneecap the Chinese tech development, right? I mean, that's what the semiconductor ban is really all about, right?
Yeah, so basically, the specific block is around leading edge or bleeding edge chips that are who have like a density of who have like a transistor density. That means like how small the transistors are on the chip, like below 14 nanometers. So each like below like each set of transistor density numbers is known as like a node size, right? In ODE node. And it's like a tier of like how dense the transistors are. So there's 14, there's like 10, then there's 7, then there's 5, and then there's 3, right? Nanometers. And obviously, the less it is, the more dense the transistors are on the chip. The more powerful the chip is because you have more compute power in the same area on the chip. And then also the harder it is to fab the chip, to make the chip, because you have to be more precise. Your machinery has to be more precise. Now, 14 nanometers is already excruciatingly precise. It's many times thinner than the width of a human hair, for example. Like 5 and 3 nanometers are even more precise. Now, the key bottleneck for getting something down further is like a physics problem. You have to use a certain. So if you have if you've had like a printer before, like a laser jet printer, you kind of understand. There's like some light that shines on some ink, right? And then voila, like text appears on a piece of paper. There's a similar kind of analogy that applies within semiconductor fabs. Essentially, there's a chemical substrate, light shines on it, and it reacts to some parts of that substrate, but light shines on it in a pattern, right, through a mask. So the in order to get that pattern down to a certain level of granularity to accommodate like a very small, circuit, like a 3 nanometer or 5 nanometer circuit, you have to use a smaller wavelength of light. So that means going from what's known as deep ultraviolet, or 193 nanometers wavelength of light, down to extreme ultraviolet, or 13.5 nanometer wavelength of light, right? And if you remember your high school physics classes, or you'll remember that the higher the wave, or the lower that number is on the wavelength of light, the higher energy that light source is, right? So basically, you need a high energy light source to be able to generate the wavelength of light that's needed to make and fab the extremely fine chips. And why all this matters is because what the U.S. IP in this whole process is just around that light source. There's a company in San Diego called Cymer, Cymer, that made that light source and researched EUV technology back in 2010 through 2012, when they were acquired by a Dutch company called ASML. Now ASML is kind of famous. They're the Dutch company that makes all the chip fabrication machines. So you can think of them as gigantic printers, right?
Is
And
this a monopoly right now? I mean, does ASML has all the production capability for the?
they're a monopoly at the leading edge. So for making the most advanced, smallest, finest grained chips in the world, they're a monopoly. For those types of printers, they're a monopoly. And each of those machines, by the way, are huge, and they're actually extremely expensive. A TwinScan 3300, or sorry, now they're up to a 3600, I think. A TwinScan 3600 EUV lithography machine costs around 130 to 160 million dollars. So it's like this, like it costs to put that in an analogy, it costs about as much as a small submarine or a small frigate, like
There
literally a
was
naval
a
ship.
there was a fire in the ASML factory in Netherlands a couple years back, right?
Yeah. So basically, SMIC, the Chinese fab, had put an order in to ASML to buy one of their TwinScan machines, and one of their suppliers to those machines had a fire, which prevented SMIC from delivering that machine to, or I'm sorry, ASML from delivering that machine to SMIC. Then ASML canceled the order. And many people suspect that that fire was, the result of U.S. sabotage, because it coincided with a visit by Mike Pompeo to the Netherlands, where Pompeo essentially laid on an extremely high level of pressure onto the Netherlands. From what I hear, he threatened to pull the Netherlands out of the F-35 project, or program. He threatened to investigate Dutch banks, because Dutch banks are tied to the dollar system, if ASML went ahead and sold a machine to SMIC. And then later on, the U.S. essentially just decided to just never approve the license to go and sell one of these machines to SMIC, anyways. So there was like a real hard, like sudden breaking right at the end of December. That was right actually when the Huawei CFO got arrested. So that was when the U.S. kicked off like the tech war. And since then, SMIC has been unable to buy one of these EUV machines, right? So they've been unable to progress past 14 nanometers in terms of fab. While on the other hand, their competitors, Samsung and TSMC, have been able to buy these machines and have been able to move past SMIC or keep progressing forward. Now, where this kind of relates back to kind of the broader technology scene is, since smaller chips are more powerful, they also mean that they're also the kinds of chips where if you build an instruction set architecture for it, it can take advantage of it can run applications quicker. It can also run applications more efficiently. And generally speaking, people who design an instruction set architecture for a chip want to design it on the smallest node size possible. If I'm Huawei, I don't want to design a chip at 14 nanometers when the market is already at 3 or 5 nanometers in my phones, right? Because the phone is going to use more power. It's not going to be able to run the latest graphics. It's not going to be able to support newer applications like augmented or virtual reality, um, and that's kind of by design. The U.S. wants to keep Chinese technology companies from being able to actually support to develop software architectures that go and support these newer applications. Now, this we can probably get to this a little bit later, but this is kind of the overriding drive, right? And where this kind of relates back to the shortages issue is when the U.S. Decided to sanction first Huawei and then SMIC. TSMC first told ASML that, hey, I don't need so many twin scan machines anymore, right? I'm like my second biggest customer, Huawei, just got sanctioned, so I don't need that much like three nanometer, 5 nanometer capacity.
TSMC, for my audience, is a Taiwan semiconductor. They they essentially have a kind of monopoly on the chip fab of the cutting edge, right? What? Go ahead.
They have a monopoly at the leading edge, again at like the 3 and 5 nanometer, but that itself is only like 20% of global chip capacity. Um,
That's also a result of Intel fucked up, right? Because Intel was supposedly to have 3 nanometer out already, but they were unable to do so.
Yeah, and Intel's like Intel screwing. Like the funny thing, by the way, is like if you think about why Taiwan has felt like it can get away with pushing the U.S. to support its independence, or drive towards independence, part of it is because Intel screwed up. So it realized that it had the U.S. in a vise, for lack of a better term, and and you can like almost draw a straight line between how aggressive the DPP, the Taiwan's governing party, has been in terms of pushing China's buttons, so to speak, and how far ahead TSMC is of Intel. There's a direct correlation between the two.
Now I'm gonna push you back a little bit because normally, from observers of the Taiwan U.S. China relationship, normally U.S. is in the driver's seat, right? U.S. is the one that set out the policies, and Taiwan usually follows. But you are claiming it's other way around. Like Taiwan is actually now setting the agenda now.
Uh, Sense to an increasing degree, not obviously not 100%, but Taiwan's no longer Taiwan. A lot of the recent um, uptick in tensions is directly the result of decisions being made in Taipei, not Washington D.C., not Beijing.
But again, I think this come about. First, I like to apologize to you because before I kind of accused you of when in our own private chat, I kind of dismiss this notion that Taiwan is pushing on this agenda because like I said before, normally U.S. is the one that sets agenda and Taiwan follows. But again, in the larger framework of things, so we came to the chip shortage situation because of the U.S. policy in the first place, right? Because the U.S. policy to cripple SMIC on mainland China, which given and just with a list of coincidences with the ASML situation and also with the Intel fuck up, that now Taiwan have a short term monopoly on the cutting edge. That's what caused it, right? Maybe we can like
It's a little more complicated than that.
oh,
So the shortage isn't just at the leading edge. The shortage is across the board, right? For the trail for like the older nodes as well. And why they're all jammed full is because then in September of last year, SMIC got banned from doing business with the rest of the world as well. And that's when like a lot of EU car makers, US car makers, other people who needed older chips, they had to shift orders out of SMIC and go find fab space in TSMC or in Taiwan's number two fab UMC, or find fab space in like Samsung, for example. Um, and there just
wait
wasn't
wait
enough
did
fab space to go
what,
around.
Euro car makers and US car makers, do they normally, I mean, I didn't even know they source a lot of their chips from mainland China from SMIC.
Well, they sell millions of cars in mainland China per year. So
Ah,
a lot of those chips are actually just for the Chinese market, right?
so the as result of US ban, say like the GM in China, now they can also buy SMIC chips because GM is still a US affiliated company. So
Exactly.
even GM factories in China producing for the Chinese domestic market now have to source their chip elsewhere from outside of China. Wow.
Exactly. You get it now. And that's so TSMC first tells ASML, I don't need that much capacity. So then ASML is like, well, I'm not going to make that many machines anymore. Then the world's capacity marginally shrinks a little bit, might have shrunk like 5%. And then the US took another like 5 to 10% offline when it said, hey, you can't do business with SMIC anymore. So add that together, that's what suddenly caused this ripple effect and created massive shortages. Um, and these well, the first Huawei ban, I'm pretty sure Taiwan did not lobby for a Huawei ban directly. They were cautiously supportive of it. The second SMIC ban, they were 100% in support of. The DPP and TSMC both jointly lobbied the United States through a variety of forums to essentially, try and cripple SMIC because they viewed SMIC as picking up all the Chinese orders that they would no longer be able to service, right? So their thought was like, you know what, to preserve our commercial interests, we'll turn around and just like nuke the whole Chinese like semiconductor industry.
Well, I mean that actually kind of makes sense because TSMC is large part of the Taiwanese economy at the moment. I mean, if you think about Taiwan, what does
Yes.
Taiwan produce, right? Like the
You,
most.
you want a fun statistic, by the way?
Go ahead.
TSMC's capital equipment budget, their capex, is $28 billion this year. Taiwan's whole defense budget is $15 billion. So TSMC, this one company, spends more on twice as much on equipment in any given year as Taiwan spends on its whole military. It is literally the national asset, the crown jewel of Taiwan. Like TSMC's like another way of thinking about it is like TSMC's gross profit of about like 35 billion dollars is almost 80% of Taiwan's annual trade surplus of $40 billion.
TSMC is a factor that matters in the
Without
Taiwan.
TSMC, like Taiwan's economy ceases to exist, pretty
Right. I
much.
mean, like, I mean, Taiwan obviously has other parts of the economy, but in terms of the world trade, in terms to the rest of the world, I mean, the Taiwan without TSMC could disappear, and there will be little effect felt outside of Taiwan.
And,
But
and what's like what's totally messed up about this is that remember that Taiwan about I want to say about 40% of Taiwan's trade, I believe, is with China, and 70% of that is a trade surplus. That basically Taiwan's entire almost Taiwan. By the way, a large chunk of that. I'm sorry, 40% of Taiwan's trade is with China. 70% of that is semiconductors. So basically, 28% of Taiwan's total trade is essentially exporting chips from TSMC into China for use in China's electronic supply chain. The whole country, like, so there's like a love hate relationship that goes on between Taiwan TSMC and the rest of Taiwan and the rest of China in this regard.
well, yeah, of course. I mean, most of the Taiwan businesses depends on the Chinese market. But at the same time, there's people from the Taiwanese government, especially the DPP government, that thinks they cannot have over reliance on the Chinese market. So they have been since. I mean, even before DPP come to power, even back in the Li Denghui era, the Taiwan government had a policy of so-called go south, right? Divest from mainland China and shift the capitals towards Southeast Asia, like build factory in Vietnam, Indonesia, etc. But none of that is quite successful just because the Chinese market is so huge and it's so lucrative. Um, And so right now we are in the timeline where um so Taiwan and TSMC, they were aligned in getting the SMIC ban, right? Because that's
Yes.
profitable for them. It's to their commercial interest to kind of shore up the chip
So
monopoly.
do you see kind of how the dominoes fall here? Like the Huawei ban causes China to invest in SMIC, and then SMIC's competitor then decides to ban SMIC, right? So now China is investing one step further. They're like, fine, we'll invest in like AMEC or SME or some. There are some other companies in China which make chip manufacturing equipment. They try to do what ASML does. So now what the Biden administration is doing is they're talking to ASML and they're saying, hey ASML, you want to try to like sanction China's like chip equipment guys too. So like the dominoes keep falling further and further deeper into the supply chain, and that's actually by design. That was like the original, like that was what like Matt Pottinger back in the Trump administration said. He's like, if we just start sanctioning at one point in the supply chain, eventually like the dominoes will keep falling until the whole like zipper. He compared it to a zipper, right? Like you unzip the zipper, and then like the whole like you can accomplish decoupling, right? Which is what they wanted.
But at this point, I think it's not just Matt Pottinger anymore because Matt Pottinger already left with the
Yeah,
Trump ad.
yeah. It's become bipartisan. But then again, that's because like the harder you unzip that zipper and the further things come apart, eventually like the two sides start seeing each other as competitors and not trading partners anymore. So they just want to decouple harder and harder. So there's like a vicious cycle that's starting to kick in right now.
Right. I mean, that's what a lot of the national security establishment wanted to push for in the first place. They
Yep.
wanted to decouple the U.S. China economy because they see the interdependence as a liability in case of conflict. Because it makes conflict with China harder when your economy depending on trade with China. So their solution is okay, we'll just decouple with China so we can get on with the Cold War 2.0 stuff.
Yeah.
Um,
Yeah. Pretty much.
yeah, and so okay, so let's walk through this timeline. So what happened after after the SMIC ban, after now that what I mean, what does the chip shortage affect? I mean, it affects automakers, it
Yeah.
affects
Yeah, it affects everybody who uses chips. So automakers, phone makers, other device makers, right? People who make like laptops, people who make servers, people who make like even like gamers, right? So you may realize that hey, if I want to go buy an Nvidia GTX like graphic card.
Following is a bonus segment for my patrons on Patreon. To listen to it, go to Silk and Steel Podcast on patreon.com, where for $5 a month, you will receive premium content like this, as well as early release episodes before they have been released to the public. I put a lot of effort into making this podcast, and I do ask you for your support. Thank you for listening, and I hope you subscribe. Bye-bye.